Hello, everybody. I will solve today another live coding session. So today I will solve this question: merge intervals. Okay, so I'm giving an array of intervals, and each element is start and end with, and I will merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Okay, quite simple. So the input should be the list of lists to the list, and each element represents the interval start and end list. Okay, and I will merge them, and the output should be the again to the array list of lists. So each element represents the interval just like this way. Okay, good. So I will take a look. If I'm giving intervals 1, 3, 2, 6, 8, 10, 15, and 18, then I will try to merge it. So for example, I'm giving 1, 3, and 2, 6, 8, 10, and 15 to 18. Okay. Oh, so there's overlapping here. So 1, 3, and 2, 6 is overlapping. So I merge them and I get 1, 6, 8, 10, and 15 to 18. Good. Cool. Okay. One thing I'd like to confirm is if I should merge 1, 3, and 3, 5 into 1, 5 or not. I mean, about the boundary overlapping. Yeah, I will take a look here. 1, 4, and 4, 5 are merged into 1, 5. So yes, I should merge them. Good. Okay, so that being said, I will think of the brute force approach. So brute force approach is, I think, it's quite simple. So I build the list of intervals. I mean, I will take a look at one by one. Now I have 1, 3 first, then I get 2, 6, and check if they can be merged. And yes, so I get 1, 6, and then I get 8, 10, and I will check if I can merge them. And no, so I just have to append 8, 10 to the returned list. So in that way, I append, intervals, or I will merge them. One thing I have to take care is if I have 1, 3, and I mean, if I have this range and this range, and it's a new ranges like this, I have to merge all these three together. So that's what I have to take care. But anyway, the time complexity should be O n squared, because as I said, I will take a look at each interval. There are n intervals. And for each, I will take a look at the previous intervals to check if there is an overlap with the new interval. So I have to take a look at all the existing ones in the returned array, and it could be up to n if there is no duplicate and when the new interval is in the end. So the time complexity should be O n squared. And space complexity is constant, because I'm just, updating this returned array. Yeah, but I think when I merge them, maybe I have to shift elements. I don't know. So, or maybe I will use the set. Yeah, because order Doesn't matter. Oh, I think it's one more question I can ask. So I wonder if return list should be have to be sorted or not. The answer is I can't find an answer from this constraint. Yep. Okay. So I will optimize this approach. So actually, this is quite a famous question. So I actually know how I can solve this. But simply saying, I will sort by the start index. No, start bar. Yep. Sort in tuples by start bar. So what happens is that, oh, it just looks like this. Yeah. But if maybe the array is sorted in this way, this comes before 15 to 18. So now, after sorting it, it looks like this. But maybe I will make a bit more, complex so that I can cover so many cases. So let's assume that after the sorting, the intervals looks like this. And firstly, I will take a look at this interval and try to merge as much as possible. So when I'm at here, this one starts until the end of this interval. This and this can be merged together. So now the current merged range becomes this length. And I will take a look at this. And I will check if I can merge them together. The condition if I can merge them together is this start begins until the end of the merged interval. So if it is true, I can merge them. And in this case, the merged interval doesn't change. And let's say I have this one. In this case, they can be merged together. So I expand this. Yes. Then let's say if I have this one, which doesn't intersect, which means that this starts after the end of this merged interval. In that case, I create a new merged interval. Yeah, I started. Yeah. So that's the basic idea. Yeah, quite simple. So what I did is sort the intervals by start. And for each interval, I will check. Merge with current merged interval or start new current merged interval. Yeah. So this is what I should do. So again, I sort them, and again I will tell you. So I sort them first, and current merged interval is this one. So I will check. I will check with the new interval, and if they intersect, merge with current merged interval merge the new interval, or they don't intersect like this, I start a new current merged interval. Okay, So this is the basic idea. And the time complexity should be now O of n, because I will assume that there are n intervals, and I will take a look at each interval. So there are n intervals, and for each, this operation takes the constant time, because I just do the comparison and merge, which takes only the constant time, or start a new merge interval, which also takes the constant time. Yep. And for space complexity, this is constant aside from the returned array. Because what I'm doing is, actually, I'm updating the current merged interval, and if it's done, it should be into the returned array. I always keep the return merged interval in the list, and I can assume that the last one is the current merged interval. The interval on which merging is going on. So what I mean to say is, I set right here, and maybe I can put the first interval here. And I will take a look at second and later interval and merge with the current merged interval. Current merged interval is the last one in the merged list, or start new current merged interval, which means that I append new element to the current interval. Yeah. Okay, so this is the basic idea. Good. Okay, I will start the implementation. One thing I have to take care is, if there is no interval in the given list, I can't do this. I have to immediately return. But the constraint says there is at least one interval. So I can say this. And this is a merged interval. And I will copy this because this interval could be expanded by the second or third or later intervals if they intersect with this. So I don't want to pollute the given list. I don't want to mutate the given list. So I updated here. Okay. Oh, and I have to sort them. Actually, I'm, mutating it here. So let me not. But if I do this, it takes O of n time. And O of n plus complexity. And now it doesn't become. So let me be a bit ambiguous here. So I sort it, but I don't mutate the first element. Good. Okay. So now intervals are sorted, and I initiate the merge list. Now we'll do from line 23. For each interval, this is it. This is the current interval, and I will try to merge. As I said, the condition if they can merge or not is if this interval starts before or equal to the end of the current merging interval, which is merging, on which merging is going on. So this should be -1. If it should be merged, I update the end index, this or this. Obviously, it is possible that the current interval ends before the current merging interval. So in that case, the end index shouldn't change. Okay. So this is the case. And I will put it here. If there's an intersection, I append current one. And which means that I start the new merge interval. Okay, this is it. So I've done this and this. Yes. So I've returned in the end. Good. Okay, I will quickly test this. So I will take a look at two test case. I don't have so much time, obviously, so I will do with simple two cases. Number one, they're intersecting partially, like this. And number two, they're not intersecting. And I think I also would like to test the case when some intersection is completely surrounding another intersection. So I think I omit this, but basically I can test like this. Yep. But I don't do it here. Anyway, I will take a look at this and this. So in this case, I expect 1, 4 only. And in this case, I expect they're not merged. Okay. So for the first one, I saw that it doesn't change, and merged is interval 0, 1, 3, that copy. So with me. Merged is now 1, 3 only. Okay. And here in line 61, length of intervals is 2, so I goes only index 1. Okay, and start and end is now 1 and 3. And has intersection is start, which is 1, is before or equal to the last one, index 1, which is 3. And this is 3 because 1 is less than 3. Yes. So this is true. So here, merged index -1, which is the last element, which is 1, 3. and 1, which is here, should be updated with end, which is 4. Hmm? Oh, wait a minute. This would be 2, 4. So this should be 2. But still, this is true. So, I mean, merge negative 1, 1 is now 3, and end is now 4. So it becomes 4. So this is now updated with 4. And this is it. I go out of the for loop and return this merged with, which is 2dr 1, 3, 1, 4. Okay, good. So I can say I passed this test case. I will quickly work through 1, 2, 3, 4 case for real quick. So merged index, merged array begins with 1, 3 only. Then the first element, 2, 4. No, sorry. 3, 4. It's 3, 4. And for Hudson intersection, start is 3. Last merged, array is 1, 2. Index 1 is 2. So it should be now 2. And this is not true. Has intersection is false. I go to line 72 and I will append other end list, which is 3, 4. Good. And I go out of the for loop and return 1, 2, 3, 4. Okay, good, passed. Okay, I covered those lines. I covered line 70 and also 72. I'm pretty confident in my code. One thing I can say is return in list is sorted by the start index, which corresponds to the first item in each tuple. I mean, in each list. But it doesn't matter, I think. Okay, I will submit my code. Good. Great, accepted. Okay, so I quickly wrap up my today's coding practice. So today I solved the question, merge in tuples. But this is quite a famous question. No, challenges actually. Yeah. And obviously for this question, the first thing I will do is load the interval by the start index. And then I traverse each interval and I will keep track of the merge interval. And I will check if the new interval can be merged into the last interval, which I'm keeping track of. And if they're intersecting, I merge the new interval to the last interval I'm keeping track of as in the list. If not, I just append the new interval into the list. And I keep doing. And finally, I return the list. Okay. That being said, I finished my today's coding practice. Thank you so much. Bye.